All right, the next one on the stage is going to be Jari Nurminen, verifying protocol traces with the robot framework at Fireshark. Please, welcome.
Thank you. Yep. So my name is Jari Nurminen. I'm working for a company called Secron. We are a Bratislava-based company, and we are kind of doing test automation for mobile network verification. And I have you one kind of say use case, which is, let's say, I would say a bit uncommon for the show, other talks that we have heard today. No user interface testing, no database verification, just protocol trace verification. So the kind of say generic use case is that you start capturing traffic on a network interface. You do something in your test case. You stop the capture and you parse the trace, and at the end you verify the messages in the trace, that you verify that all these expected messages are in the trace. Let's say our use case for that one is that since we are doing a mobile network verification, we start the network traffic capture on a network element, then we make, for example, a phone call, or let's say trigger a handover on the phones, and at the end we verify that all the expected messages, protocol messages, are in that trace what we captured. How is it done? From the architecture point of view, we use the robot framework SSH library to connect to the network element, start the protocol capture on the network interface there, usually simple TCP dump. And then at the end, we stop the TCP dump process and download the traces using the SSH library. And then when we have the PCAP file on our PC that is running the robot framework, we use the Wireshark to decode that PCAP file so that we have something, let's say, human readable. And then we use, let's say, our self-developed keywords that are verifying the protocol messages inside that trace. So how does it actually look like on the test case level? Quite simple. You start trace and you have variables there which contain the trace host IP addresses and the interfaces that we want to start the capture. And then you do something there, just omitted the steps where we are making the phone call. And then at the end, we stop the trace. And that stop trace keyword then kind of downloads the PCAP files and does the parsing and so on. And then at the end, we use this verify trace keyword to find the messages that should be in that trace. So the next slide shows a couple of details how the keywords work. So in the previous slide, I said that that there are some variables that are containing the host names or IP addresses. This is then how it looks on the code. And then, as I said, the start trace keyword starts the TCP dump on those interfaces, and the stop trace is downloading it and parsing it. And then the actual verification looks like this. Let's look at the first one in more detail. So basically, we have a list of regular expressions that we expect to match one BDU on that trace. And now on the bottom, you see the Wireshark kind of decoded text dump, and you see the kind of matching lines. So that keyword, what we are using to verify, it checks, let's say, each protocol packet and expect to find all the regular expressions in that packet and matching them. If not, the test step will fail, and the usual stuff. Then you have kind of a failed test case, and kind of you have then also the link to the PCAP file that you can do the kind of troubleshooting afterwards just by clicking the link, and the Wireshark opens, and you can look at the actually what went wrong. Then on top of that one, there's also kind of thing which is called correlation. So if you look at those the verify trace keywords. The first argument there is a Boolean, which is in the first case true, and the second verified trace keyword is false. Means that in the first test case, first step, we find any message that is matching that list of regular expressions. And the second verified trace is then matching that second regular expression, but on top of that one, it has to be part of the same transaction or that was triggered by the first one. And that we saw in the Wireshark trace. So the first step, the same regular expression match as earlier, and you see this call ID, which is kind of part of the, let's say, session initiation protocol that identifies the call in the network to, let's say, to be one call. And then the next verified trace actually finds, again, that regular expression which is there. But behind the scenes, it also knows that it should look for the same call ID that the first verified trace step actually had. So that was kind of it in short. But you might also then want to ask, okay, why do we actually want to verify the traces, even protocol traces? Because if my test case passes, like for example, the phone call is working, why should I actually care about the traces? At least in the mobile network business. All the boxes in the network are, let's say, coming from maybe from different vendors, and they are black boxes, and you basically, you as a, let's say, mobile operator, you don't have necessarily access to inside those boxes. So you basically kind of are forced to, let's say, verify the traces to see, what is happening between the boxes. And that's kind of relatively easy because those interfaces are kind of standardized. And the second good thing there is actually, which these traces actually also are very useful, is the fact that it kind of, let's say, it helps you in this blame game, because in the traces you can see, okay, your box sent something wrong to my box, so fix your stuff. It's not my problem. So you can easily point out where the problem is coming from. That's it. Questions?
Nope. Noni? Okay, now it works. Hey, so not really about the robot, but basically in these sort of scenarios and a couple of like similar kind of situations, what I've seen is also that when you have this kind of a client and server communication or peer communication, you might end up like the client or the server is actually responding also additional or like having additional stuff. So do you have any sort of like idea, or do you also verify that there are no any extra stuff? For example, if the client receives a packet and then it responds correct way, but then it also might add some other stuff which the server might not be expecting. So do you have that kind of verification, and how do you, if yes, how do you handle that?
Well, kind of, let's say not automatically out of the box, but as a part of this test design, when you're designing these steps, you are also then kind of, you need to consider, okay, what do I want to verify? I want to verify that these arguments or these parameters are inside this one message, but I also want to verify that these parameters are not inside the message. So that kind of stuff is there, and also then using kind of standard robot features that, let's say, complete additional message. You could try to verify that for that additional message, but expect that keyword to fail then if it's there. So kind of test design. So.
Okay, thank you very much.